Welcome to The Debate. Today, we are opening a file that, well, most physicists consider completely closed, sealed, and archived for over a century. We are re-examining the origins of the special theory of relativity. Specifically, we're debating the central thesis of the book Newton and Relativity by Francesco Cester, Manfred Clemente, and Hans Michael Korf. I'll be arguing that Cester's work successfully demonstrates that relativity is a logical, even inevitable extension of Newton's laws, specifically regarding variable mass and the momentum of radiation.
And I will be taking the opposing stance. It is a bold project and, frankly, a highly controversial one. I maintain a deep skepticism about deriving relativistic effects without the foundational postulates, like the constancy of light speed. I'll be arguing that this approach, while mathematically elegant, likely just hides Einstein's assumptions somewhere in the classical basement.
It's a fair concern, but let's set the stage. The standard narrative of physics history is stone-cold solid, right? By the late 19th century, classical mechanics, Newton's world, had supposedly hit a brick wall. It just couldn't explain the behavior of light or electromagnetism. Then Einstein arrives in 1905, sweeps the board clean with two radical postulates, and gives us an entirely new universe.
Exactly. And Cester seems to be challenging that foundational narrative.
He's doing more than challenging it. He is rewriting it. The authors posit that there never really was a brick wall. My position is that the historical separation between classical mechanics and relativity is largely artificial. If you strictly apply Newton's second law in its original form and combine it with the electromagnetic knowledge that was already available in 1884, you don't just get relativity. You are forced into it by the math. You can prove E equals mc squared using classical physics principles available well before 1905.
Which, if true, is a massive historical what-if. But my position is grounded in the philosophy of the physics. You cannot simply tweak Newton to get Einstein. Newton's universe is built on absolute time and absolute space, a rigid stage. Einstein's universe destroys those concepts. While I acknowledge you might be able to derive E is equal to mc squared, classically, the constancy of the speed of light is a unique, bizarre phenomenon. It usually requires a hard postulate to explain why it violates Galilean relativity so blatantly.
And that is exactly the accusation we need to test today. Let's start with the first pillar of Cester's argument, the classical origins of E is equal to mc squared. Now, usually, we are taught this equation drops out of special relativity. But Cester, building on work by Max Born and others, argues this relationship was derivable as early as 1884.
1884 is a very specific, very intentional date.
It is. It's the year John Henry Poynting published his work on the transfer of energy in the electromagnetic field. This is absolutely crucial because it is 3 years before the famous Michelson-Morley experiment of 1887, the one that failed to find the ether, and obviously decades before Einstein.
Right. So we are firmly in the classical era here. Poynting gave us the Poynting vector, which describes the directional flow of electromagnetic energy.
Exactly. Poynting established a law for the momentum of electromagnetic radiation. He showed that for radiation, momentum, which we call P, equals energy divided by the speed of light. So P equals EC.
I accept that premise. Maxwell's equations were already suggesting that light exerts pressure. But we need to be very precise here. In 1884, when Poynting wrote P equals EC, what exactly did C represent?
That is the pivotal question. In 1884, c was simply the speed of propagation of the electromagnetic wave. It was just a parameter derived from the electric and magnetic constants of the vacuum.
Right, it was thought to be relative to the ether. It was not yet the universal speed limit. It was certainly not considered constant for all inertial observers. It was just a number, about 300,000 kilometers per second.
I want to emphasize this. The momentum of electromagnetic radiation does not explicitly contain the constancy of the speed of light within it. Poynting's law just says, essentially, light pushes.
Correct. A constancy of the speed of light for all inertial frames was absolutely not postulated at that time. And that is what makes Cester's starting point so incredibly strong. He takes this simple,
pre-relativistic law from electromagnetism, just the fact that light has momentum, and uses it to prove that energy must have mass.
The center of mass thought experiment.
Yes. It's deceptively simple. Imagine a closed, completely isolated box floating in deep space. Inside, on the left wall, you have a light source. On the right wall, an absorber.
Okay.
The source flashes. A pulse of light shoots across the interior of the box.
What happens to the box itself?
Basic action and reaction. The light carries momentum to the right, so the box must recoil to the left. It physically moves while the light is in flight. When the light hits the absorber on the other wall, the transfer of momentum stops the box.
Precisely. So the physical box shifted position in space. But here is the problem. This is a closed, isolated system. Newton's laws dictate that the center of mass of an isolated system cannot change its position unless an external force acts on it. That's the paradox. The geometric center of the box moved left. So for the mathematical center of mass to have stayed stationary, as Newton demands, the actual distribution of mass inside the box must have changed.
Exactly. Something had to physically move from the left side to the right side to counterbalance the shift of the heavy box. That something was the energy of the light pulse itself. If you sit down and do the algebra, just balancing the mechanical momentum of the box against the electromagnetic momentum of the light pulse, EC, you find that the mass required to balance the equation is exactly EmC squared.
So solely to preserve the conservation of momentum, which is a strictly classical Newtonian law, you are forced to assign mass to that transit energy.
Yes! You get E equals mc squared using only 1880s physics. No Lorentz transformations, no relativistic kinematics, just the strict requirement that the center of mass stays put.
I will grant you that this is a fully valid derivation. Einstein himself used a very similar argument later on to reinforce the concept. It clearly shows that inertia and energy are intimately linked. But, and this is a big but, this is the easy part.
How so?
Because acknowledging that energy has inertia doesn't actually break classical mechanics. It just adds a new variable. You could theoretically have a universe where equals mc squared is true but time and space are still absolute. The real break, the part that makes relativity what it is the speed limit. The idea that nothing can go faster than c, and that c is the same for everyone regardless of how fast they're moving. In Newton's world, velocities simply add up. If I'm on a train going 100 miles per hour and I throw a baseball forward at 100 miles per hour, the ball goes 200 miles per hour. Cester has to explain why that stops working for light.
And that is exactly where the variable mass shift comes in. This is the engine of Cester's entire theory. It's where we turn the corner from static analysis to dynamics.
You mean revisiting Newton's second law?
Yes. We all learn F equals ma in high school. Force equals mass times acceleration. But that is actually a simplification. Newton's original second law, his lex secunda, was F equals dp dt. Force is the time derivative of momentum.
Right. Mathematically, momentum is mass times velocity, mv. So we are taking the derivative of mv with respect to time.
And if you remember your calculus, the product rule tells us that the derivative of mv splits into two distinct terms. You have the change in velocity, which is m times dv dt, and you have the change in mass, which is v times dm dt.
But in standard classical mechanics, we almost always cross out that second term. We assume dm dt is zero because mass is constant. You don't get heavier just because you start running.
But we just proved that isn't true. In step 1 with the box experiment, we proved E equals mc squared. Energy is mass. As you accelerate an object, you are doing physical work on it. You are adding kinetic energy to the system.
And since you are adding energy, you are, by definition, adding mass.
Exactly. So dm dt is definitively not zero. This is the critical fundamental insight. If you plug the mass energy equivalence back into Newton's second law, you create a mechanical feedback loop. The faster you go, the more kinetic energy you have. The more energy you have, the more massive you become. And the more massive you are, the more force it takes to accelerate you further.
It's a law of diminishing returns. You are pouring energy in, but instead of just gaining speed, you are gaining inertia, heaviness.
Cester does the rigorous math on this. He combines the standard work energy theorem with this variable mass concept. He substitutes the terms, solves the differential equation, and what pops out? The relativistic mass formula. Mass equals rest mass divided by the square root of 1 minus v squared c squared.
There it is, the Lorentz factor.
Yes.
The square root of 1 minus v squared c squared. This is the undeniable signature of relativity. It dictates that as velocity v approaches c, the denominator shrinks to zero and the mass balloons to infinity.
Creating a universal speed limit.
But wait, I need to pause right here, because this is the exact moment where I feel the classical label just peels right off. Cester addresses this directly in the book, specifically in Chapter 5, and I want to quote this accurately because it's vital to my point. He writes, "One thing is certain, with the alternative derivation of the dependence of mass on the velocity, we have finally left the field of application of classical physics and entered the field of relativity theory, especially since the formula in question contains the Lorentz factor."
He does say that.
So he admits it. He fully admits that once that formula appears on the chalkboard, we aren't in classical physics anymore. We have crossed into Einstein's territory.
He admits we have entered the territory of relativity. But the debate we are having is about how we got there. We didn't teleport there by assuming Einstein's postulates from the jump. We walked there using Newton's boots. The math of variable mass, which is strictly Newtonian momentum conservation, plus Poynting's 1884 energy law, forced the existence of the speed limit. We didn't ask for a speed limit. The conservation laws demanded it mechanically.
It is a compelling derivation. I will absolutely admit that. It creates a tightly self-consistent loop. But here is the lingering problem with these alternative, dynamics-first derivations. They often work beautifully for energy and mass, but they fail when you try to explain kinematics, how we actually measure speed and time.
Go on.
The defining feature of special relativity is the constancy of the speed of light for all observers. That is the part that profoundly violates common sense. If I am in a rocket flying towards a light beam at half the speed of light, I should measure that light hitting me at 1.5 times c. Newton says so. Galileo says so. Einstein says, no, it's still exactly c. That is usually an axiom. It's a starting rule, because it's so counterintuitive. How can Cester possibly derive that bizarre behavior from Newton?
This is, in my view, the absolute payoff of Cester's work. He uses a simple law from electromagnetism and shows how the constancy of the speed of light can be proven purely theoretically. He treats it as a theorem to be derived, not a postulate to be swallowed.
How? You can't just spawn a universally constant speed out of thin air.
He uses a velocity addition derivation. Imagine two particles colliding and sticking together, a completely inelastic collision. We analyze this collision using conservation of momentum and conservation of energy. Standard classical setup. But we use the new variable mass formula we just derived.
Okay, so we are doing a standard collision problem, but the masses are now relativistic masses, constantly shifting depending on their velocities.
Right. When you solve this complex system for the velocity of the resulting combined particle, or if you reverse the mass to find a relative velocity between two frames, you derive a very specific formula for adding velocities. You get V total equals V1 plus V2, 1 plus V1 V2 c squared.
Which is the famous Einstein velocity addition formula.
It is, but look what happens when you plug c into that formula. Let's say our particle is actually a photon. I am on a train moving at velocity v, and I shine a laser forward at speed c. According to Newton's simple addition, the total speed is v plus c. But plug those same numbers into the derived formula.
Let me visualize the math for a second. The numerator is v plus c. The denominator is 1 plus v times c, c squared. One of the c's cancels out, so the denominator simplifies to 1 plus vc.
Exactly, which, if you find a common denominator, is mathematically equivalent to c plus vc.
So the v plus c in the numerator cancels out the c plus v in the denominator, and you are just left with c.
Always c. It doesn't matter how fast the source v is moving. It could be 99% the speed of light. The result of the addition is mathematically locked at c.
Velocity addition formula, which enforces the speed limit, is simply the only mathematical way momentum can be conserved if mass varies with kinetic energy.
Yes, the conservation laws themselves enforce the speed limit. If you allowed velocities to add up linearly like baseballs, v plus c, you would literally violate the conservation of energy because the mass accumulation wouldn't balance out before and after the collision.
So Cester's argument is that the constancy of light speed isn't some weird, magical property of light itself. It's a structural necessity of any universe that conserves momentum?
That is the core thesis. It completely demystifies the postulate. Remember, Poynting's law in 1884 didn't assume c was constant. It just gave us the tool, the momentum of radiation, that eventually proved c must be constant to keep the thermodynamic and mechanical books balanced.
It is incredibly elegant. But I have to play the philosopher here for a moment. We are still just talking about mass and energy, but relativity is famous for changing the stage itself, space and time, length contraction, time dilation. Usually in a university course, we teach those geometric changes first because they form the fabric of the universe. Cester seems to be putting the cart before the horse. He's doing dynamics first, geometry later.
He reverses the standard pedagogy, yes. But I would argue he is putting the horse, the physical forces, and the energy in front of the cart, our measurements of space and time.
Explain how he gets to geometry then. How do you get shrinking rulers from exploding mass?
Once he has the velocity addition formula and the mass relation locked in, he sets up another thought experiment. He looks at orthogonal collisions, particles hitting each other at right angles, like an intersection.
A standard setup to test transverse momentum.
Yes. When you analyze this sideways collision from a moving reference frame, you have to ensure that momentum is still strictly conserved in all directions. For the equations to balance, knowing what we now know about how mass balloons with velocity, the physical distances in the direction of motion must mathematically shrink.
So from that, he derives length contraction, the L square root 1 minus v square c square formula.
He derives length contraction as a strict mathematical requirement for the conservation of transverse momentum. And then directly from length contraction, he derives time dilation.
This implies a fundamental, almost philosophical shift in how we view physics. Einstein's view, at least how it's commonly taught, is the geometry of space-time is curved or distorted, and therefore objects moving through it behave differently. Cester's view seems to be objects must obey conservation laws, and therefore our measurements of space and time must distort to accommodate those laws.
Precisely. It turns relativity from a theory of pure geometry into a theory of mechanics. It makes the weirdness of space-time feel much more inevitable, grounded in things we can touch, like inertia.
Inevitable is a strong word, but I see the deep appeal for a Newtonian purist. It saves the laws, even if it ultimately destroys the classical definitions.
It saves the utility of the laws. It tells us that Newton wasn't fundamentally wrong about how force and momentum work. He just had incomplete data regarding the mass of energy.
But does it truly save Newton? That is my lingering doubt. Newton was very specific in the Principia. He wrote extensively about absolute, true, and mathematical time. He believed in a rigid, unchanging stage. Cester's math, even while starting with Newton's F equals dp dt, ends up shredding Newton's stage just as thoroughly as Einstein did.
It shreds Newton's philosophy. I completely agree. But it validates Newton's intuition about physical laws. Newton cared above all about the physical data matching the math. If Newton had known about 1884 electromagnetism, if he knew that a beam of light physically pushed back on a mirror, he would have done this exact derivation. He would have seen that his own second law, strictly applied to radiation, destroys his concept of absolute time.
You really think Isaac Newton would have accepted time dilation?
I think he would have accepted it if his own calculus proved it was necessary to save the conservation of momentum. Newton hated baseless hypotheses. He loved rigorous proofs. Cester provides a proof that starts right in Newton's backyard.
It is a fascinating reverse engineering of the theory. It effectively argues that the hard division between classical physics and modern physics is artificial. It's a continuum.
Exactly. And that we didn't necessarily need a full-blown crisis in physics to discover relativity. We just needed to take the Poynting vector to its absolute logical conclusion.
I will concede this much today. Cester's work successfully removes the magic from the speed of light. It stops being an arbitrary universal speed limit that nature just randomly decided on and becomes the strict structural limit required to keep energy conserved.
The structural limit required to keep energy conserved. That's a great way of putting it.
But I still think there is profound value in the geometric view. Thinking of space-time as a flexible fabric is deeply intuitive, especially when you move forward into general relativity and gravity. I do wonder how Cester's mechanics' first approach handles the curvature of space-time.
That might be a perfect topic for a future debate. But for special relativity, the flat space dynamics approach seems to hold up remarkably well under scrutiny.
It certainly forces us to respect the dp/dt term in Newton's equations. It's not just a mathematical formality we can cross out. It's the loophole that lets the entire universe bend.
Indeed. It seems the seeds of the relativistic revolution were hidden in the original classical laws all along. That brings us to the end of this analysis. We've walked the path from Newton to Einstein, not by jumping across a conceptual chasm, but by simply following the breadcrumbs of momentum.
It has been a rigorous mental exercise. It definitely challenges us to rethink what we consider fundamental in physics. There is clearly much more to explore in Cester's material.
Thank you for listening to the debate. Until next time.